at the end of the day. And as I said, your theme of the college that I saw is really very apt, that you're searching for meaning in the bits and pieces of life. Whereas I think this workshop is going to help you search for the meaning of physics in the bits and bytes that you'll come to know from the attempting various computations. As I said, uh, it's always this workshop could not have been timed better, because if you see, UGC right now has introduced in its curriculum a extensively computational based syllabus, and this is tailored on Python. So it could not have been better time, and this is really the foresight of your institute, which actually speaks volumes about its leaders, that they can gaze into the crystal ball into the future and prepare the students well in advance, giving them a edge over their in this highly competitive field. As I said, I'll come to computation a bit later, but if you see, I come from an institute which is an inter-university center of the UGC. So our actually name is UGC DAE Consortium for Scientific Research, where we hope to make available the mega science facilities of the DAE to the large pool of university research community. And we at the Kolkata Center have a very special task cut out for us, is to address or cater to the northeastern region. And in this sense, we have been organizing conferences at Manipur, Shillong, and at in the state of Nagaland. So this is really a very good opportunity for me to come and speak to you. And I hope that this will open a doorway to the collaboration between you and us, where the researchers can use. And the most important thing to understand, all our facilities are available to the university researchers free of cost. You do not have to pay for a characterization facility. In fact, we support your travel, and we also support a small amount of student a fellowship for 3 years if a project is approved. But if you want to use our facilities for one time, you just have to write to us. We take care. Of course, in this testing time, we have not been able to extend much of support, but we will soon be restarting it. So we are always open. We have we have a chemistry department, physics department, biology, computational things. So you are always welcome, and I hope that this will give us an opportunity to start a new beginning. So and of course, the computations have now really gained by leaps and bounds and have become an integral part. And the other day, I was giving a talk to 12th standard students as to why they should be taking up basic science as their career option. I stress that physics, chemistry, biology today has an underlying tone of computation which makes them ready for the daily challenges ahead in their real world. So if many of our students have in fact started doing, after doing their doctoral degrees in physics, have gone on to do extensively well in the field of computation. So this is really an opportunity which you should also keep as that. That's the spin-off you get for doing basic science. And as I can see, Dr. Barua has been an expert who she gazes at the stars. And as I said, both the physics and humans are made in the skies. So it is always a privilege to come here and talk to you. And well, I should apologize to Father Reverend Jose that when I was doing my schooling, I did my schooling from St. Paul's in Mumbai. Don Bosco's would usually be our rivals in the football. And okay, it's funny, I would know who would win. But as I said, it's always a privilege to come back to an elite educational institution which builds up the foundations of humanity. And of course, once you are a good human being, you are obviously going to get educated. So in fact, I should thank you all for giving me this opportunity to be present in that very elite institution. Of course, I just learned that Father Mavli was the first principal of the college in Northeast who got the NAC credential. So that really speaks volumes for the organizational capacity. And it's, in fact, there's something that we can learn from by associating with. So it's always a pleasure and a privilege. And of course, Parag, I think, attended one of the conferences we had organized, and that's how we came to know. And what is most interesting about Dr. Day is that I think he has tried to, as a physicist, to talk to technologists and try to make the technology guys understand physics. And in that sense, he gets the best of the best world. So with this, I hope we are going to have a fun-filled a learning experience for the next 2-3 days. So happy computational to you all, and let's hope this journey in the field of computing is as interesting as the journey would take to the picturesque state of Assam. Of course, I have traveled to Guwahati several times on my way to Kaziranga, so now I'll definitely make a stop and try to spend some time with you. Thank you, and I really look forward to this wonderful workshop. Thank you.
Thank you very much, sir, for your kind words. It was really interesting to know the deep interest you have in our university. And then, definitely let this be the beginning of a new collaboration between our university, which can get so much from your institute, sir. Thank you very much for your words. And then going ahead, let me now invite the head of department of the physics department, Dr. Samrat De, to give us the highlights of the activities of the Department of Physics. Dr. Samrat.
Thank you, Amor. Welcome all the participants. I thank you for choosing this workshop, and I also thank the university for always encouraging us to go ahead with this type of workshops and other events. And my special thanks to Dr. Ghugre, and thank you very much, sir, for your offer of assistance for different scientific collaborations. We hope that we'll be benefited from you. And for your kind information, our university just lies somewhere in between Guwahati and Kaziranga, where you went. So next time you come, definitely you visit our university. That will be a privilege for us to have you here. Regarding the activities that physics department has been organizing, to tell you the truth, it will take at least 1 hour of time to speak about all the activities that we have done for last 2 years or so. It has really become our habit to organize at least 2 or 3 workshops every year, 1 national conference every year. And we have been very successful in organizing those events. Our main motto is to help our own students and also the students of other areas of Northeastern region. And we have been lucky enough to have their confidence in us. So I'm not going to speak on the past events that we already had, but I'm just going to highlight 2 of our events that will be happening in the month of February. One event will be Science Academy's refresher course, sponsored by all the 3 science academies for theoretical physics. And the dates will be from 1st to 16th of February. And we are also thankful to Science Academies for choosing our university to have this refresher course, which is of course a very rare event in Northeast India. And also we are having one international conference on 5 different sub-themes, and that will be held on the last week of February itself. And this is in collaboration with Indian Association of Physics Teachers. So both Indian Association of Physics Teachers and Assam Don Bosco University, we are jointly organizing this international conference. And I inform all the participants who are present here, including the speakers, to spread this information to your friends and colleagues. We hope that those events will also be successfully organized. Coming back to this event, Mr. Parag Bhattacharya has been working this computational physics workshop for last 2 years. This is the third one. Yes. And he has been an expert in this field. And he recently attended one of the computational physics workshops where Dr. Ghugre was there as a resource person, and he actually mentioned that it will be an opportunity for us to listen to him, and that's how where we are now, Dr. Ghugre with us. And I welcome him once again, and I welcome all the participants once again.
Thank you very much, Dr. Samrat, for enlightening us with the activities of the department, especially which is coming ahead, and then so that we can look forward to it. And as we go ahead, let me request the convener of this workshop, Mr. Parag Bhattacharya, to give an overview of this online workshop on computational physics 2020 using Python. Mr. Parag.
Thank you, Dr. Amar. I hope I'm audible.
Yes, Parag, yes.
Okay, first of all, I would like to just make a brief correction to what Dr. Samrat had said. He called me an expert. I disagree with that. I'm not an expert. As a kid, I used to love taking apart my toys. I'm still that same kid. I just like to take apart things and just learn this curiosity which is leading me to Python. So that's the reason. Okay, so I'm not really an expert. I'm just trying to find my way over here. And whatever way I have found so far, the idea of this workshop is only to share that with the students and everybody who's interested to learn. So now coming to this workshop, this is the third such workshop in this particular series called as Workshop on Computational Physics. The first workshop was in 2018, and that year we had done this workshop using MATLAB and GNU Octave, because I did not know Python in 2018 at that time. Then a couple of years ago, after that workshop, I was introduced to Python by one of my students from engineering. I used to teach BTech students in the Azara campus. And one of the students from the computer science department, he introduced me to Python. In fact, he had introduced me to many other things also, like such as Bitcoin and cryptocurrency. So he told me about Python, and then I felt a little curious and I started exploring about Python. And then we realized that, okay, the same thing can be actually done, the workshop which we had done. So with the very next workshop, which is in 2019, the workshop on computational physics 2019, we had it using Python, but we used the Python IDE for that particular workshop. So what has happened to me is work coding in Python. It started first as a hobby, but now it has turned into a serious tool really for me. And from my perspective, I found Python to be more like a friend. I used to do a lot of coding when I was like from my class 11. From that time, I used to do a lot of coding. I'm basically a C++ person. I had done a lot of coding in C++. So when I got introduced to Python, C++ is, if you think of programming languages like people, so C++ was like a mentor, okay? But I found Python to be more like a friend, okay? And when I code in Python, it was like having a casual chat with a friend, okay? So for me, Python was basically like it's just a friend. I'm just having a casual chat with a friend. And as Dr. Samrat had mentioned, I had also, and Dr. Ghugre had also mentioned about that particular workshop that this year, which was held it was organized by the Victoria Institution College in Kolkata. And in that workshop, Dr. Ghugre was the resource person. So when I attended that workshop, my perspective towards Python had changed. So far, like I said, it was working with Python was like having a casual chat with a friend. And when I attended this workshop, and I realized that I can also have a serious discussion with the same friend. So that's when I started really exploring Python seriously, and then tried to use it in my own research work also. And I found that it's really makes my job a whole lot easier. So as a scientist, I find it really helpful, because it gives me time to focus on the problem at hand rather than on the specifics of the coding part. And this year, this particular workshop being online, it also gives us the opportunity to focus on topics which are of some really specific use to all of us as scientists. So this time we are going to focus on packages such as NumPy, Matplotlib, and if time permits, there's a very exciting package called as Pandas. So maybe I'll introduce you to that also. And for that, and just so as to drive the point that using Python, you focus more on the problem and less on the specifics, on the details of how to do the programming. So we're going to use, instead of the Python IDE, we're going to use something called as a Jupyter notebook. My talk in the first technical session after the keynote address will basically introduce you to the Jupyter notebook. So let me just show you the schedule. You all have already seen how the schedule looks like. So I'll just share it here so that I can just go through these just briefly. Amma, just let me know if you're able to see my screen.
Yes, Parag, it's loading.
Okay.
Yeah, we can see. We can see now.
All right, so this is basically the program. So for each page, it gives you the program for that particular day. So, and in this schedule, you'll also find out in the third column, you'll find out the Google Meet link. So these Google Meet links, we are going to use the same Google Meet link for that particular session. So right after this inauguration, we'll have the talk by Dr. Sandeep Ghugre, and that will be followed by a brief presentation by me on how to go about using the Jupyter notebook. And then we will break for lunch from 12 to 1 o'clock. And from 1 to 3:30, I will introduce you to the elements of Python. So how to get started working with Python. And all the resources from today, from day one, that is today, it is made available. It will be made available to you at the end of the day on this link. So it's this is basically a shared Google Drive. You just click on this, it will take you to a Google Drive, and over there you'll find all my files, all the Python notebook files, all the resource files, everything you'll find in that particular location. So you can just go to this link and you can download for today's work. Then that will be the end of the sessions for today. Tomorrow, on the first technical session, that is technical session 3, we will have a talk by Dr. Samrat De, the head of the Department of Physics at Assam Don Bosco University. He will be introducing you to the fundamentals of numerical analysis. And he will be followed by me again. I will be showing you how to do physical computations, how to take a physical problem and then perform computations using Python. And then we'll have a break, and then we'll follow it by taking some actual examples and then working on this. Because the best way to learn Python is actually to solve a problem. So we will be taking a lot of problems and we'll be solving them in the session after lunch tomorrow. And just like today, all the resources that we use in tomorrow's session will be available in this link. Then that will bring the second day to a close, and after that, the third day, we have only just one session. The first session, in the first technical session of the third day, that is technical session 5, we will have applications of Python. Okay, we'll continue with where we had stopped in the previous day. That will be followed by a quick question answer session by myself and my other resource person who is Dr. Samrat De, and that will be followed by the valedictory function. And all the resources from the third day will again be made available on this link. So that's basically in brief how the program schedule for this particular workshop goes. So to finally talk about what to expect from this workshop, you need to know that this workshop is not meant to be a full course on Python, because to learn Python, to master Python, you need years actually to know in and out of Python. So this workshop is not meant to be a full course. It is merely meant to be like an appetizer for which will tell you that there are better things to come. So I hope this workshop will inspire all of you to get started with Python coding, and it will make you realize that coding in Python is also one of the means of expression for the scientist in you. So with this, I would like to wrap up. Thank you.
Thank you, Mr. Parag, for taking us through the activities of this workshop. I think, it's going to be really exciting. I'm really excited about the things, and then like
Present now.
Hello. Okay, sorry, there was a technical problem. So with this, we have come to the end of the inaugural session. But before we end, let me take this opportunity on behalf of the organizing committee to thank the Vice Chancellor of this university, Father Stephen Mavli, for his encouragement on all these activities. And also, let me take this opportunity to thank the Register of our university for being with us and addressing the gathering here. And we are also grateful to the Director of School of Fundamental and Applied Sciences, Dr. Manmayuri Barua, as well as the Head of Department of Physics Department, Dr. Samrat Dey, and all the faculties present here, as well as the participants. Thank you very much. So with this, we have come to the end of the inaugural session. But immediately now, we will continue with the keynote address by Dr. Sandeep Ghugre, who is from UGC DAE CSR, which is Consortium for Scientific Research. This is like a bridge between universities and Department of Atomic Energy. Department of Atomic Energy being a research-oriented organization, have lots of scientific tools with them, which universities will not be in a condition to have it. So this Consortium for Scientific Research is a bridge between universities to avail the facilities of DAE. So this is a very, it's a very novel concept that the facilities are made available to the universities. And as Sir has already said, he is also very much interested in our university. So hope we can make use of the facilities available in UGC DAE CSR Kolkata in future. So may I invite the keynote speaker, Dr. Sandeep Ghugre, to give the keynote address to the gathering here.
Hello. Yeah, thanks a lot. As I said, it's always a pleasure and a privilege to come and talk to students and, of course, share with them the excitements that we have encountered. So, as I said, let me start. Just give me a minute. Yeah. Is my screen visible? Hello?
Yes, sir. It's visible.
Yes.
And, if somebody has any questions, one of you can just volunteer to look at the chat box, and then you can always stop me as and when you have the questions. As I said, this is intended to be a dialogue rather than a formal inaugural talk. So you can always try to stop me, and we can have a dialogue rather than just a monologue. So as I told you, computations are an integral part of any basic research. As I said, in physics, the various branches, mechanics, condensed matter, atomic and nuclear, electronics, each one of them has an underlying computational tone to it, which really prepares you to look at the problem, gather the tools you need to analyze it, and as Parag said, the very fact he admitted that he's not an expert and he's a learner itself shows that he really has acquired knowledge, where you really are about the entire topic, where it makes you more humble rather than boasting about it. And the beauty about Python is, as he rightly said, it's a friend in need, it's a friend who sees you through your difficulties. And for me as a student, quantum mechanics and mathematical methods still give me nightmares. So let me today try to tell you how you can try to befriend these two demons, which really used to give me sleepless nights before the exam, problems in Shom series for my Fourier analysis or maybe Griffiths for quantum mechanics. Let me try to tell you how Python will try to make them more friendly to you, and you slowly start looking at why things happen, or the numbers that you get, do they really make sense? So it may get you thinking in an overall manner, which is really very important to look at the totality of the situation you are in and make the best use of the resources you have and come out with the required solution. So as I said, I plan to do, I do not know how much time will permit, but as I said, we had this workshop and I'm sure Parag has the material from that workshop, and he can share it with you all, because that is the main building block of the open source movement that we have. That we don't keep anything locked up in our cupboards, but we always free to share and distribute them so that everybody benefits from them in the long run. So, as I said, all physical, chemical, biological, engineering sciences are and have and predominantly experimental sciences, and therefore computations become a part and 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 parcel. Whether you need it, you love it, you hate it, it's always there. And basically, all the computations can be split up into these basic three things. Any experiment would need you to acquire data. Once you have acquired this data, you would need to look at it, analyze it, process it. As some of my friends call it, we do the characteristic data massaging, and then we try to visualize it in a manner that which I can derive some results out of it. And last but not the least is, of course, the manuscript preparation, because that's the end goal of any research activity. You need to have a paper at the end of your work. The otherwise you are really in for a difficult time when your boss questions you as to what you have been doing. So all these three things can be beautifully done using Python, as I will try to show you. Now, if I look at the ways when I started my own PhD career way back in 1990s at the then what was called the Nuclear Science Center, this was the kind of a huge data acquisition system we had, which was called the DECWAX. And if you guys need to know the history of DECWAX, our railway online reservation was actually built on the VMS. That operating system was a VMS, and that is one which brought in the railway reservation system. And this was actually the compact disk. It's a 50 GB compact disk on which I stored my data for the first time. And this was a prized possession which would be kept by the system administrator locked in his cupboard. And whenever I needed to analyze the data, I had to go beg, borrow, steal from him, put it on and read the analysis. So as I said, today I think my son's iPod has a 2 TB of data for him to store his song. Whereas my first experiment, this was what we had was a 50 GB price possession of, and the entire experimental data went on this. So if you looked at the data analysis in the good old days, this is what I'm saying, when because all of us who are doing basic science at the end of the day aspire for a career in research or development. So if you saw in the good old days, this is what were the tape drives on which we put data. This was the digital wax system was the main breadbone for any large scale experimental facility. We had to literally be present in the lab 24/7. Lab was our actually second home, because we had to sit down, access the tape drives, sort the data, resort it. In fact, just to give you a fact, what took me 7 days of computation today is done by my PhD student in less than half an hour. So that's the kind of advancements we have made in computations, which has made not necessarily life easy, but at times has taken out the fun from doing things. Because when we were in the lab, you'll see most of us would spend times, have coffee together, chit chat, and suddenly decide, there's a good movie, let's go and make. So the human aspect was much more there in the olden days technology than it is there today. So everything comes with a price. As they say, there are no free lunches. And the end, if you see, you may be wondering what I'm saying. This was the tools for us to make manuscript. This was what we would use to trace our graphs on a tracing paper. We had to run behind draftsmen, plead, borrow, bribe them with a cup of tea or coffee, and have your graphs and made ready for manuscript preparation. It was really a laborious job. The software resources then there were all proprietary. You had to pay for it. In fact, Unix was patented to AT&T. So they had VMS, the DEC Ultrix, they had SGI. These were all proprietary operating systems. You had proprietary software, which was Fortran, Pascal, C. And there was entire proprietary. It was a locked door technology in those days. We needed dedicated graphics terminal to do our analysis. You had to book them beforehand, and if you had to wait in queue for maybe months together. Of course, what has not changed is the manuscript preparation in LaTeX, which was still there, it has been made a bit more easy. So these were the software resources when we started, and the real game changer came in with the advent of personal computer, the desktop and laptop, which became affordable. Previously, in our days, we had to sit in the institutes and do our analysis on the mainframes. But now, with the availability of the personal computer and open source, these together going hand in hand, you did not have to spend a single naya paisa to have a proprietary OS. A Windows Home Edition costs around 6,000 to 7,000, but a Linux comes free. So the availability of open source, thanks to the guy Linus, who actually made the revolutionize the entire computational field, we were able to have affordable computational power right on at with me. So nowadays the students are rarely seen in lab. Their computer centers have disappeared, and mostly they have been replaced by tables where students sit with their laptops and do the analysis. That is because of these two. And of course, it has the main, besides this open source development, it was the development in toolkits which has made the real game changer. So it was the combined confluence of availability of open source resources and toolkits which has opened up the entire new vista. Now, what do I mean by toolkit? Now, we obviously know in computers there's something called the 1090 rule. This was the basis when they got the RISC, the reduced instruction set computer, is the 1090 rule. 10% of the instructions are used 90% of the time, and 90% of the instructions are used 10% of the time. So all that we need to do most of the time is read our data, do some processing, and then visualize the data and prepare publication, good quality publication graphs and figures. All these three things can be done. And of course, I am not an expert in computers. I always had problems whenever we went to conventional programming languages such as Fortran, C, C++. They are meant for experts. They are meant for professionals. A layman like me is really because then I suddenly realized if I want to do an addition of two numbers, I have to define what is A, I have to define what is B. Is it integer? Is it real? Then I have to define what is C and take care of all the syntaxes and nitty-gritties, which really scares us. So the toolkit is something which knows that you are not an expert programmer. It knows you are going to make silly mistakes, and it corrects for you automatically. So that is the main advantage of toolkit. They are not rigid as the conventional programming languages. And they're extremely flexible and user-friendly. You really can learn them off the net in a day or two. And most important is there's an extensive collection of libraries with algorithms for doing anything and everything that you need to do. As Parag has said, these are all called packages in the language of Octave and Python. They are all called packages. So you have some good, kind-hearted soul doing you a favor by developing all the tools and putting them online. And most important is they are available for all major operating systems. Previously, people thought open source was only restricted to Linux. Of course, I may love or hate Bill Gates, but nowadays the Windows operating system has almost become a free operating system. It's become an affordable operating system. You should definitely not have, I do not advocate piracy, but definitely a decent Windows operating system is affordable within the reach of any student pursuing any research. And therefore, once you have the Windows operating system, there are several free softwares available for Windows. And this was an emphasis which was put to me by our then director, that if you need to develop some tools for the use of colleges, it has to be on a Windows platform, which is more user-friendly rather than Linux, which really needs some amount of knowledge of system administration. And at the end, as we always use call them, you become more of a system misadministrator rather than an administrator. Am I audible? Everything is fine? Or
yes, sir. You're audible, sir.
Okay, thank you. So that because this virtual platform gives you the advantage that the other person or the other may also doze off, and you would really not know. So that's why I just need to keep on checking to make sure that at least a few souls are around and listening to me for and other things. So that's why. So anytime you have any problem, you can just always interrupt me. So basically, in fact, as Parag said, we actually started our journey with Octave because we had a lot of engineering students come and do projects with us. And they would always use MATLAB, and MATLAB fleeces your pocket to the nth level. So we found out that Octave was a poor man's replica substitute for MATLAB. And we started with Octave and then slowly migrated to Python. Also, we found out that since UGC has now hardwired Python into curriculum, many of our research scholars who went back and started teaching in colleges, they always came back. They have kept in touch with us. And they came back to us that, sir, we are having some problems. Can you help us develop a code in Octave, in Python? And then they started doing more of Python. So that's how we are in Python, merely by in response to the difficulties faced by our students. And in fact, the workshop that Parag mentioned was one of the students wrote back to us that we have heavily they have converted the entire quantum mechanics into computational quantum mechanics. Can you just help us with Python? And then we started trying to help him, and that's how the entire workshop has evolved. So as I said, we will try to look at Python, which is a toolkit which makes up for all my fallacies and shortcomings. It knows where I'm going to make mistakes and then tries to correct. So now let me tell you or run you through what is a Python and how is it helpful. And since this is really kind of a first lecture where I'm not going to be that technical, I can afford to tell it to you in a story form. So let me tell you the story of the RC circuit. In an RC circuit, which is the most innocuous looking subject that we look, but it teaches you almost the basics of computation that you would want to know. For example, we all know that, yes, I have an RC circuit, I have a capacitor, it stores charge, it blocks DC. So what I can do is, if I start charging this, I apply a voltage, let us say 5 volts across an RNC, the voltage will rise up exponentially. We all know that. That is the textbook level knowledge we have. Now let me try to tell you how Python will help you understand the nitty-gritties of this entire effort. As I said, I know the voltage across a capacitor at a time t is given by this relationship. So basically what you like to do in your experiment is apply a fixed voltage and then measure the voltage across the capacitor. Now this, actually, following that, the first workshop, I gave a second workshop where I then dealt with actual experiments. And we had an experiment where I can measure this. Again, using open source tools and techniques, we use Arduino, the microcomputer controller, to record the growth of voltage across a capacitor, and we recorded the time and voltage format. So I'm not going into that experimental detail, but let's say there was a good friend of yours who said, oh, look here, I have a file. It's an ASCII file. An ASCII file is a human readable file where I have stored the time and the voltage across a capacitor. So I had 1 second, it was 0, 2 seconds, it went to 0.5 volts, 3 seconds, 0.75, so on and so forth. So now I have this file. Can you help me look at this data? As I said, most of the time, what we have to do is read the data and plot the data. So that is a simple thing, and people who have done the conventional programs would come and first ask you, okay, you have a data, can you tell me the data format? Is it a 2-column data? Is it a 3-column data? Is it, so what is it, real numbers? What is the delimiter? So on and so forth. And then you say you had enough of it and you are not going to do anything more to help it. But if you have Python, as I said, Python has several packages which does all these things for you at the back of your hand. So what it does is, I have the data stored in a file. So I just, there is a file data rc.txt which has this ASCII file. One line of it reads in the entire data. You do not need to know what was the format, how many columns were there, nothing. You just give this command, the computer will go and read. You know, most of the time data are stored in columns. So it will put it in data colon dot. Suppose it was a 2-column data, it will automatically, this simple command will pull it out into 2 columns, data colon 0, data colon 1. If there were 3, it would be data colon comma 2, so on and so forth. So without knowing anything, somebody gets a file, tells you it's an ASCII file separated by maybe tab, one single line will be able for you to pull it out and read it. Once you have this data pulled out, as I said, anybody who does C or Fortran can immediately see the power of Python it has. In C, you would have to know the number of lines that are there, what was the format, you have to initialize arrays, so you had to know what was the length, and so on and so forth. But one single line has got you the data in X and Y column. A simple command like plot data, this was the X, this is Y, you have an XY plot that is shown here. So in the simplest sense, you have been able to read a data file without knowing the format of the data. If you go and tell this to people who have actually handled data format, they will really be amazed that the amount, because unless you know the data format, you cannot read a data in C or Fortran. Of course, I have been limited to C and Fortran, so that's why I keep on repeating this. But here is an example. You know you have an ASCII data, just read it. The program does all these things for you. So now you have done this. Fine, your friend is not happy. He says, now I want to see. I know what is the value of R and what is the value of C. Now you have given me this data, but how am I convinced that this data is what it should look like? The next question, the answer to this question is, oh, well, I know the value of R, I know the value of C, I know the value of time because it's a timestamp data. And I know what was my V0. So then let me calculate the value of the voltage as a function of T. All that you do is something like this. Now this is blasphemous in conventional Fortran, in any language. You cannot define a dimensionless array. But then the program knows that you are not an expert, you do not know most of the things, so it does all this. You can define a dimensionless array, a blasphemous thing in conventional computer languages. So what I will do is I have 2 arrays defined to store the voltage, theoretical voltage across a capacitor and the voltage across a resistor. So I just read in there, as I told you, I have able to strip it into columns. So I just call them X time, Y time. I'm sure this you will do more and more when you start doing it, but just these are exercises to show you what you can do with Python. Then I just do these calculations. These are the various voltages that you are calculating. So you calculate Vn exponential X time divided by RC, you will get all these kind of things. You do the calculation and then you go and you see it beautifully fits your experimental data. So you have immediately been able to visualize the data. You are able to do some calculations now and present to the user the calculations with what you expect and what you get. And that is what an entire exercise is supposed to mean. And as I said, you are able, we try to calculate the voltage across the resistor, which will be falling down. You try to calculate the theoretical voltage, and then you try to do various kinds of things. As I said, some of the programs may not, because we keep on tinkering with them, but this tells you V in minus, that's actually the voltage theory will be, I always like to write V0 minus V0 into this. So that has certain advantages. I will come to it in a later. So you're basically calculating what is the expected voltage at a given time if you know the value of R and C and you try to calculate it. So what you did was you gave your friend the voltage it predicted and what was the theoretical voltage you get. Fine. So what you have done for your friend is you have been able to show the data he got, you've been able to do some calculations and show him. But now your friend is still not happy. He says, look, I know that the voltage across, suppose your friend has got you a data, which is the voltage across a capacitor in an RC circuit. He does not know the value of R or C. He knows one of them, but he does not know the other. So how can you help him? So he comes to you and tells, look, I need your help and I know one of the values. Can you help me predict the value of the other one? So common sense tells you that you have a functional form like this. The functional form was the voltage across a capacitor is V0 minus V0 E by T by RC. So what you will tell him is, okay, I know the functional form. I have this data. Can I fit this data to this functional form? Well, of course, I need to know the time. The time, since I have measured it, I have a handle on time. So what I do is the experimental data, which is absolute truth. Our interpretation may change over time, but not the data. That's your absolute truth in the truest, purest form. So what you would do is say, okay, I know the functional form, the functional form the data has. I know one of the variables, time. Let me try to predict for you the tau. So what you would do is you would go and say, okay, this is the data I have, X and Y. Let me fit the data to V0 minus V0 exponential minus T into tau, or T into 1 by RC. So the data that I have should be fitted into this form. There are mathematical tools to do it. I'm not going into the details. But if you are able to have a data, you tell the data that this is the functional form it should follow, it is able to fit it and give you the value of these unknowns. So what I do is these are called least square fits. So you do a least square fit by using one simple line in Python. You tell it, I need to fit the X and Y, that is time versus voltage data, into a functional form which is defined as V0 minus V0 e to the power minus T into tau. You provided all these unknowns, you will be able to find out the value of A, B, and C. A and B should be exactly identical. That is why I like to write it in this form. So you can be able to fit the given a data. If you know the functional form the data is to follow, you can fit it and calculate your unknown. And then just a simple one-line program where you give it the X data, the Y data, you tell it what is the functional form, and then you are able to, you see, you get the fit. Once you have the fit, you will get the value of tau, which is unknown. You have to know R or C, you can calculate the other. So your friend, what got to an time, what's his voltage data, you are able to plot it for him, you are able to calculate it theoretically for him. You also fitted the data to a known functional form and then told him what was the value of RC. So you have increased the complexity of the problems you would face in your laboratory. Of course, I assume most of you are new to Python. I'm sure at the end of the workshop, you would be familiar with most of these. And these are the small things that you will find it very useful when you do your laboratory sessions or you do your actual numerical calculations for your quantum mechanics or mathematical method. So as I said, the simple RC circuit, which is so innocuous, we really don't spend enough time about it, can teach you the various routine things that you need to do in your lab. Now, as I said, let us further increase the complexity. Somebody comes and questions you, look, guy, how do you know that it should follow this functional form? As I said, you start questioning yourself. You start questioning the data you have taken and try to make sure whatever you have a feel that, okay, this is the data it should look. The very fact when you plotted it, you knew, aha, it has to be an exponential rise, it looks like it. Then you did a theoretical calculation from a known functional form and you saw it fitted. Then you try to fit the data and get one or more unknowns. You see everything is fine. Now you have asked the ultimate question, that how do I know that this is the equation that the voltage across a capacitor has to follow? We all know that this is a first order differential equation. So I have an equation whose initial value is unknown. So these are known as ordinary first order differential equation. I'm really not going into what is first order, what is ordinary, what is inordinary. But let us suppose you have an equation with you. What you do is you divide the entire interval into equidistant points and calculate the value at each subsequent point such that xn is equal to x0 plus ns. So you try to discretize a given function. And there are various methods you have to solve these equations. You will be familiar with one of them is the Euler method. And what we do in Euler method is you try to find out the value of y1 is equal to y0 plus h. The h was where I have done the difference between the points and using its value at the previous occasion. These are called, there are implicit methods, there are explicit methods. I'm not going into it, but you know that the voltage across a capacitor can be written in form of a first order differential equation, which is dq by dt v minus q by c by r. And now you need to solve it. So there are, as you know, that the differential equation can be solved using mathematical techniques, one of them being the Euler technique. And this is how you write a program to do a solution of differential equations using Euler. You see, I wrote y was equal to y naught plus h into fx naught y naught. So what I do, of course, I need to know the initial values. I know v naught was 5. The initial value of the voltage across the capacitor was 0. So I wrote a differential equation, and using Euler's method, when I broke it into equidistant steps, I was able to calculate it. So then, once I have this solution, I plot it. So what I did was, I said, oh, I know that the voltage across a capacitor is the solution of a first order differential equation. I knew the equation V minus Vy by Vt by C divided by R. The equation is here. I have to solve this using, there are various methods. You must have studied them, Euler, Runge-Kutta, Crank-Nicolson, so on and so forth. But Euler's is the simplest, and I can solve it by calculating the value at the present step from the value known at the previous step. And lo and behold, you see, this was the data that I had given you. And this is the solution of the differential equation using the Euler. So starting from all the basics that you need, as I said, do not be scared as to how I have done it. There is no black magic or witchcraft in it. It's a simple, plain Python programming, which I'm sure Parag will introduce to you, and Dr. Dev will talk to you about the underlying numerical method. But as I said, the simple RC circuit, I read and plotted the data for my friend. I did the theoretical plots. I fitted the data to the known functional form. And I also derived the functional form that it should follow, all using Python. So this tells you the power of Python that you have. Each of this is a building block. Once you have them, you are able to do everything. And you are able to put these various building blocks together and then build up a comprehensive understanding of the entire process involved. As I said, I've slowly increased the complexities from a simple read and plot to actually doing some calculations, to doing some fitting, Because most of the time you'll see, you'll have your data, somebody will come and tell you the functional form, you fit the data to that form and then derive the unknown, or you could also solve the equation. So this is the story of RC circuit, which tells you most various level of complexities that you can handle using Python. Now, once you have the data, most of us have faced the problem of representing the data. We need to represent it so that we can derive, because data is a bunch of numbers. What you make out of it depends critically on how well you are able to represent it. So represent, what you do is, once you have the data, many a times you have X and Y data. As I told you, you had the data or time and voltage. Now, if your data is reliable and correct, it should have a predictive power. You should be able to predict what would be the outcome at a point where you have not performed the measurement. That is the main emphasis of doing any experiment. Doing an experiment, the results should be able to give you a crystal ball to gaze into a scientific future or scientific past, depending on where you are looking at it. So given an XY data set, you need to derive a model. You know that if I have, most of the time we know that all phenomena in nature are linear. If one banana costs you 10 rupees, two bananas should cost you 20 rupees. Now, if you go to a big bazaar or a big basket, they may put in some discount, which are slight deviation from the linearity. But everything in life, most of the time, is linear. So if I have a data set X and Y, I can model an equation of a straight line. Y is equal to mx plus c. So I have the values of X and Y. There is a mathematical trick called the least square approximation, where I can derive the values of M and C, which will represent a fit to my data. So what I do is I perform the measurement at certain X and Y, and then I try to model them so that I can predict what would be the value of Y at a point X where the measurement has not been done. This is known as a least square fit. It is, if you are to do a least square fit using any conventional programs, you will have to know X, you need to know sum of X, you need to know sum of X squared, you need to know sum of XY, and there are these equations. Now, if you remember, I forgot to mention one thing. The holy book for any computational physics is something called Data Analysis by Bevington. If you look up, the latest edition of Bevington is scary. There was an old 1970s edition, which is about 100 and 150 pages. If you find that book in the old Chor Barzak, please buy it and keep it. That book, which is a very small, in fact, it's not even A4 size, it's half the size of A4 and about 200 pages, it teaches you all the tricks of numerical method. If you read the latest edition of Bevington, you're going to get scared. So if you see that there are several methods to do this, but if you have your friend Python, it does it for you. All I need to give it X and Y and tell it I need to fit a straight line to it. It will be able to do a least square fit to the data without you really bothering to know what it is. Once you have done the fit, you then basically, so that it gives you, this is the functional form. You will have fit 1 and fit 0, which represent my, mx plus c. So one of them is f0 and one of them is f1. So then once you have this, you can see that at a given value of x, using the value of y and c, how does that equation look like? So this is a simple linear fit to the data you can do in a line. So if I give it 2, it will fit it to a second order polynomial. If you know that, if for example, when you drop a ball, s is equal to half ut plus half gt square. If I drop it, u is 0. So I have s is equal to half gt square. So if I have a form, if I know S and I know T, I can fit it to a second order. If I know S, I know T, I fit it to a second order thing. I'll be able to calculate the value of acceleration due to gravity, an experiment which is done at your BSc. So this is how. Hello. Yeah. Are there any questions so far or anything that I? Hello.
Yes, you are audible.
No. Any questions or anything that I need, or I can carry on?
You can please carry on. Yeah.
Fine. So this is how you have done. This was your data, and this is the fit you get. You plot it and you see it. As I said, it may be looking too much of a job for the people who are not exposed to Python. But let me assure you that by the end of this workshop, all this would start making sense to you. As I said, the other thing is you have a set of data. You really need to present it and look at what are the meaningful data sets. So that is done using what we call the quantiles. That if you have a range of data set, you arrange it, and try to see whether this data fits into a group. Are the readings very closely spaced or they are deviant? The various ways to look at it, you look at they look at quantiles, the first quarter, the 3/4 quantile, so on and so forth, which tells you that if you make a series of measurement of the same quantity, how well coordinated or correlated these are, and these is usually presented in a box plot which looks like this. So this was my data set. It tells me my median was here. This is the range between 1/4 of the data set and 3/4 of the data set, and these are the widely discrepant points. So whenever you make a repeated measurement, you like this box to be as squeezed as possible. So people who do statistical analysis will appreciate this. This is what they call the box plot or the whisker plot, where they really try to represent how closely or how identical these data sets are. And this is a simple 2-line code. As I said, these codes may look Greek and Latin to you at the moment, but please do not be scared. I'm sure by the end of this workshop, you would be able to run most of these codes and tailor it for your own applications. As I said, so this is what you do most of the time when I like to read data, plot data, fit it, and get some value and present the data. Now let me talk to you of some of the applications of Python in our daily UG and PG curriculum. So I'll just skip this. I'll come to this. Now we know that most of the time in mathematics and in quantum mechanics, you are faced with transcendental equations. Those are equations which have to be solved either graphically or analytically. They cannot be expressed as an algebraic operation. Now, if you have this equation, sin x is equal to x squared by 4, it is a transcendental solution. What you would do is, you would then plot sin x, you would plot x squared by 4. So what I'm doing is I'm plotting sin x and x squared by 4, and I see where they intercept. That is the solution of x. So my x will be somewhere around 1.9. This I've been able to get by looking at the plot of sin x, plot of x squared by 4, and where they interact. Or what I see is I do sin x minus x squared by 4, and where the solution interacts, technically we say there is a change of sign before. So if I have a function fx equal to sin x minus x squared by 4, before the root and after the root, there is a change of sign. So the change of sign helps you determine the solution of a transcendental equation. Or I can plot the two functions where they intersect. That x value gives me the solution. And if you see, I plotted sin x, x squared by 4, they intersected here. So around x equal to 1.9 is my root of the equation, which again is confirmed by the point that at x equal to 1.9, there is a change of sign. Now this can be done using Python by doing just two simple plots. or I calculate sin x minus x square by 4 and I plot it and I see where this has changed the sign. So that is how I get my equation to transcendental equation. I can also solve them analytically using another package called SciP. And what I do is I tell it, of course, all the root finding methods need an initial guess. If you give a wrong guess, you may not be able to get them. So that is how what I did was I did three things. I plotted sin x, x squared by 4, see where they interacted. I plotted fx equal to sin x minus this, see where there was a change of sign. And I also solved it analytically. And I do find all of them gave me a result, or the root was around x equal to 1. So this is how you can solve a transcendental equation. Now, if you ask me why have I spent so much time on a transcendental equation? Now, these equations are of paramount importance in quantum mechanics. This is a graph most of you have seen in your quantum mechanics book by Griffith. And you have wondered that how this graph has been made. Let me tell you, this is nothing but the solution to the transcendental equation for a finite square well potential. If you do all the mathematics for the square well potential, as I told you, I will try to increase the complexity. Here, I assume that I know the solution to the square well potential is represented for even n and odd n. And this is nothing but the transcendental equation that I showed you. Sin x and x squared by 4. These are just the generic name. So if I know the equation, the energies for the particle bound in a square well, finite square well, is a solution of these transcendental equations, where we do some mathematics to make some dimensionless quantities, which is well defined in your Griffith, and I just solve these two equations. That I have this and I have this, and I plot them together. That's what I've exactly done. Tan E, if you see, and on the other side it was one. I calculated the cot E, and then I did under square root V by E squared minus 1. That's what it stands for. Sorry. This is in terms of energy, this in terms of depth of well. These are all standard things you can find in your test. So I've just borrowed the last equation and then I just ran these plots. So this is the energies of a particle having energy trapped in a potential of 15 volts. Wherever they interact, you will have the even and odd solution. So this is a standard problem. It's actually a problem from Griffith. If you see it, this problem I think has been solved in the Griffith. Now you can actually compare the results that Griffith has given after doing all the complex mathematics and your simple program gives you. In your Griffith, you'll find they have told you now what happens if you increase the depth of the potential. You start wondering what happens, what not. All you do is change this value. If the potential is made more deeper, make it 50. You'll see the number of solutions decrease. You'll see by reducing this, solutions increase. And whatever is written in the Griffith's book, you will be able to do it yourself and convince that yes, it is actually what happened. Simple way, I knew the solutions, I knew the functional form, I know the transcendental equation, I just plot. It's as simple as plotting the two functions. Of course, it may give you some error because of divide by 0, but don't bother. Again, your conventional sieve or Fortran program would have crashed the moment you have a divide by 0. This guy knows you are an idiot and you are not that much of an expert programmer. You may make a mistake, so it forgives you and just gives you an error that you did some divide by 0. I forgive you, and then you start continuing. So this is this I like very much to present to the students, because this is something we see in our books, we by heart it, but we have never really learned how to do it. So once you have the Python, a friend to talk to you, it makes quantum mechanics it was really scary for me. Quantum mechanics, Griffiths, really gives me the scare. But now I think I understand some of these. So this is something which you know of an equation in quantum mechanics. And similarly, your scattering form of potential, you think all these problems can be solved. In fact, we have solved them and shared with Parag. If he does not have, just let me know. I will send across all the material. So that's how you have been able to use this friend to befriend the beast which they will give you the night. Another thing which always gave me, of course, some of these I have done because of my own personal difficulties I faced when I was a student. We all know quantum mechanics. Yes, we have to talk of Schrodinger equations. And the moment you talk of Schrodinger equations, you have heard there is eigenvalues, eigenvectors. You need to diagonalize the matrix, this, that, and you have lost the entire flavor. Because mathematics at times scares people away. Of course, it scares students like us, me at least, away. And so I needed a friend which would befriend me with all these things. The moment I talk of Schrodinger equation, I end up with what are called the second order differential equation. Now, there are numerical tricks to solve such equations. So this is a trick we use to solve the first order equation. This is the trick we use to solve the second order differential equation. Now, please note it is yn plus 1 minus 2y n plus yn plus 1. You will see these full in books. There you will have Mathematica which gives you codes to solve Schrodinger equation for harmonic oscillator, finite potential, and you really do not know what was happening. Let me try to take a few minutes and explain to you what is happening. Please remember this equation, n plus 1, n, and I think one of them is n minus 1. This should be, I think, n minus 1. There's a typo. Yeah, it's n minus 1. So if you see this second order equation can be written as y n plus 1 minus 2y plus y n minus 1. So this was my differential equation. Now, having this differential equation, I'll say I'm going to use 5 points to solve it. I know my boundary condition says 0 is the wave function has the value 0 at the endpoints. So y0 and y5 is equal to 0. I just have to determine this 4 values. So what I do, I say j equal to 1. I will have psi 2 minus 2 psi 1, and this would be 0. So for j equal to 1, I have minus 2 psi 1 plus psi 2. For j equal to 2, this will be 3, this is 2, this will be 1. So I repeat for 1 to 4, and I get this. This matrices you will see in all numerical books which talk about using numerical methods to solve Schrodinger equation, but they do not explain how you have got it. So simple method, you will see that you will have minus 2, 1, 0, 0, and if you look at it, you end up getting what are known as banded matrices. So this is what I do whenever I have a second order differential equation, d2y by dx square. It is simply written as n plus 1 minus 2n plus n minus 1, and you get matrices like this. And you will have, I always like to work in natural units where I take h, m, e all become equal to 1. That makes life easy. So you are left with such matrices. So you have what we call the kinetic energy matrix. You have what we call the potential. You add them together is what you call the Hamiltonian. So Hamiltonian is nothing but the total energy of the system having kinetic and potential energy. Kinetic energy is represented in a banded matrix because of a form like this. So you make the kinetic energy matrix, you make the potential energy matrix, you add them together, you have your total Hamiltonian. The moment you have your Hamiltonian, you diagonalize it. And diagonalization means you write the characteristic equation and then solve them. You get the eigenvalues. You put them into some equational form. You get the eigenvectors, which finally gives me the wave function of the particular system. Now, this, as I said, once you set up this equation, this may look a bit tough or scary, but just give it some time, go through it. When, after you see that, you will understand how we have got it. And then this is the simple program to do it. I have a potential. I think I have taken an x squared potential. You can take an harmonic oscillator potential. You can take a square well potential. You change this potential and you have the solution of the wave function and energies to a particle in a harmonic oscillator, particle in a square wave, so on and so forth. You make the kinetic energy matrix. As I said, the kinetic energy matrix has the principal diagonal as -2, -2, -2, and on either side it has 1. So that's how you are able to make these banded matrices. I think you can try these programs, print it out, see yourself. I made the potential matrix. I make the Hamiltonian. Of course, this H is not the Planck's constant, but in this H corresponds to the difference H we have used here. This H is actually. So I had the box, I had the length going from -6 to +6. I do it for a certain number of points. And what I do is, so I build up my Hamiltonian. A simple line, as I told you, NumPy has programs to handle most of the things. Hello? Hello? Am I audible? Hello?
Yes, sir. Yes, sir. You're audible, sir.
Okay, okay. So once I have the kinetic energy, I have the potential, I can construct the total Hamiltonian in a matrix form. This is the most simplest method to do quantum mechanical problem. I have one line of code to diagonalize this matrix. In fact, to begin with, you can have a simple 2 by 2 matrix, run this line of code on it. It will give you the eigenvectors, it will give you the eigenvalues. You can check with the various identities that they make sense. So, and then you actually solve a real time equation. And then these are just some bookkeeping you have to do because of the way it prints out the result. So this, the most important step is here. Once you have done this step, you have values which will give you eigenvalues, vectors will give you eigenvectors, and then I'm just doing some bookkeeping. And this is some normalization that I do with my 0. And lo and behold, you have the wave function for a harmonic oscillator. This is what you know is for 0. It has one node. This is for the first order. This is n equal to 1. And you see they are all out. So that is how you can actually visualize the entire process that you have studied. So you can use this to solve your square well potential, harmonic oscillator potential. You put in the form of a potential, you would be able to get the eigenvalues, the energies, and the wave functions. You do a normalization. So this is actually what you see in your textbook is something that you can actually do it yourself and see. Let me talk of one more application of this in statistical physics. All of us have studied heat capacity. And heat capacity, you know, again, it involves the moment you have integrals, you hit a bottleneck. To solve most of the integrals, you have to use either some approximation, some low temperature approximation, some high temperature approximation. And but if you have Python has libraries, packages, which actually does this integration for you. So this I thought was the best example to talk about some of the mathematical abilities of Python, which actually reflects in your, this is the heat capacity we have all studied. You have the device model, you have the Einstein model. Of course, in the Einstein model, there is a catch here. You have to remember N actually stands for 3 because it has the 3-dimensional harmonic oscillator that it has X and Y and Z degrees of freedom. So you had these humongous, scary looking equations. You see, Python allows you to do these kind of a numerical integration. So integration can be done numerically. You really don't have to solve them explicitly. And then you see, what I did was there was a data available on for CV and temperature. What I did was, as I told you, I'm able to do a fit. So I have temperature, which was my independent variable, and specific heat, which was that is, they have measured specific heat at different temperatures. And then I told my program, look, these are my two X and Y. I need to fit it to Einstein model, which is, if you remember, Einstein model was CV is equal to NKB. Let us call it X squared, H omega, e to the power X by T. Exactly what I wrote. 3 Na into Kb into X squared, N exponential something minus 1 divided by this. And you, for d by, you remember this, there was an integral. So before I fit this function, what I did was I calculated this integral used numerically. It is possible that you do a numerical integration. So I told my program that whatever data you have to fit it to this model, and it is able to give me the value of X and Y. And you see, this is the data points. If I assume the Debye model, it gives a particular fit. If I assume the Einstein model, it gives a fit. And at low temperatures, it will fit to the T cube plot. That CV versus T cube would be a straight line. This also you can check it and verify yourself. So this is some of the applications that you have of Python in your normal everyday teaching. This is what something we talked about, because most of the workshops in Python, they only talk about the basics of Python. They really don't show you how you can apply it. So here are some of the examples. You can use it to do your absolute everyday numerical calculations which you face in your text. Another thing we found was very important and very useful was when I talk in terms of signal processing. You know that given a signal, we physicists like to view it in the time domain. Engineers like to view it in the frequency domain. And you can go from time domain to the frequency domain by using what is known as the Fourier transform. This is what you do is it really gave me a nightmare as a student when I had to use some series to understand Fourier series and then do the Fourier transformation. But Python or any numerical toolkit allows you to do this transformation from the time domain. As I told you, I had two signals centered around 40 Hertz and 120 Hertz. And you can see 40 and 120, and the other harmonic was 1/3 of it. So I made a signal. In computation, that's good. You are the God. You can make anything that you want. So you make a signal like this. You saw it in the time domain. Yes, it looks like this. And then you did a Fourier transform. A fast Fourier transform when you went from time to frequency in one simple step. These again are something which I do to plot it properly. But if you just plot FFT, you would have seen two peaks. The second peak will have 1/3 the amplitude of the first peak, because that I have given it to be 1. So you made this signal out of two kind of frequencies, 40 Hertz and 120 Hertz. And indeed, this signal, when in the time domain, when viewed in the frequency domain, is actually looking to have two peaks around 40 and this. Another thing which you can see is talk about the various filters. This is the filters that we usually do, RC, CR, a combination of them. I know the relation between the input and output voltage. I just do a plot, and you can see even various filters. If I have a step response, how do I see the step response? So I can have a CR, RC. All that I have to do is simply change this equation. This is the equation which the various forms are for a CR, RC, CR-RC, and a CR. Because this is something which we need in nuclear physics, and therefore I have tried to do this. So this is how you can use Python to look at various aspects of signal processing. I guess I leave it with you at that. This was one of the pictures I actually was able to have a sighting of. I think next time when I'm on my way to Kaziranga, I will have a stop interview. Thank you.
Thank you very much, sir. And thank you very much for your very interesting talk. And then the use of Python for dealing with physics problems. That was very interesting. And yeah, on the onset, it may look little difficult, but yeah, at the end of this workshop, we hope that the
Yeah.
students will be able to appreciate it. And sir, yeah, we are very much looking forward to future collaboration. And as you have also mentioned, if you're anytime coming to Guwahati, please do visit us. And we will be very glad to have you in our department. Thank you very much, sir.
I will send this slide across so you guys can put it up. And I think Parag has my talks for my last workshop. That also you can share it with your participants.
Oh, okay. Okay. Thank you very much, sir. Sir, and then participants, if you have any questions while sir is still with us, you can discuss and interact with him. So participants, if you have any questions, you can on your mic and ask, or you can type your queries in the chat box.
Yes, we can take a few questions. If you have questions, please feel free to ask 1 or 2 questions, or if there is a problem with your mic, you can also type on the chat, in the chat box.
I think most of the students will take some time to go through it. But as I said, my child wanted to tell them that this is possible, and I'm sure the workshop will make it possible.
Yes, yes, sir. Yeah, as you mentioned, yeah, maybe it will take little time to digest. Yeah, since we have no questions from the organizing part as well as the participants, let me take this opportunity to thank Dr. Sandeep Ghugre once more. Thank you very much, sir. And then going ahead with the session now.
Pleasure, and we hope we can remain in touch. Thank you.
Yes, sir. Surely, sir. Going ahead, let me now invite Mr. Parag Bhattacharya to take his session on Introduction to Jupyter Notebooks. Mr. Parag.
Thank you, Amar. And I would like to first of all express my gratitude to Dr. Sandeep Ghugre for delivering such an illuminating talk in such a short span of time. I know it's difficult to actually cover so many diverse topics within just 1 hour. So I'm really thankful, sir, and looking forward to more interactions with you in the future, and probably more involvements and cooperation between your institution and our department. Thank you so much, sir. So like sir had mentioned, Dr. Sandeep, he is going to provide us the slides, and he has already given permission to use the material. In fact, I wanted to ask him after the workshop whether I can share the material from that other workshop which I had attended in the month of June this year. And since he has already given the permission, so what I'm going to do is I'm going to put all his files inside that shared Google Drive. Okay, today at the end of the day, I'm going to put all the files over there. You just need to go to that link which is there on your schedule, day 1. Okay, that link which is there at the bottom for the resources. You go there and you'll find all the slides over there. Okay, so and Dr. Sandeep, it will be nice if you can just email your slides from today's lecture so I can share that also. All right, so moving forward, what I'll be doing now is giving you a demo, because you have already had witnessed illuminating demonstrations of the use of Python. So what I'm going to do now is I'm going to show you how Jupyter notebooks, how they actually work. So first, it is going to be just a gentle introduction to Jupyter notebooks, just to show you the capabilities of Jupyter notebook, and then we will go into further details of the same. Okay, so let me just begin by sharing my screen. Oma, just let me know when my screen is visible.
Yeah, it's coming now. Yes, it is visible now.
Okay, so this is how a Jupyter notebook looks like. Oh, I can hear some noise here. All right. I would just like to request all the participants that just keep your phone, cameras off and your mics muted. In case you have a query, you can just feel free to unmute yourself and ask a question. All right, so coming to the Jupyter notebook, this is how a Jupyter notebook looks like. Okay, more about this later. First, the best way to convince somebody is to show them of something is to show them how it works, right? So I want to convince you that the Jupyter Notebook is a really good and very easy tool to use. So how do I convince you? I'm going to show you I'm going to show some demo here. So before I actually go and try to explain what are these things that we see over here, running clusters and all these, before I explain all of this, let me just go straight in and give you a demo. Okay. So there is this demo file which I have created. And when you open this, when I click on this one, when I click on this, it is going to create another tab, and in that tab, this is going to appear. So right now it's empty, as you can see, there's nothing over here. Okay. Now I'll try to demonstrate to you why it is called as a Jupyter notebook. Why notebook? Okay. Why? What do we use notebooks for? We use notebooks for obviously taking notes, right? So if you have any ideas in your head, you can jot down those ideas in a notebook. So Jupyter notebook, it allows you to do that only. Okay. It allows you to jot down ideas. Now suppose as a scientist, let's say, okay, I'm thinking about stuff, right? What's happening around me. So I could have many different ideas coming. Some of these ideas could be abstract ideas. Some of these ideas could be, how to implement specific, problem. So if I were to write a notebook, it would contain, it would consist of text. It would consist of programs, okay, program codes, not the entire program, just parts of the program code, and it will also include probably something like diagrams. Okay, so those are the things that could be there inside a notebook. So this is how a Jupyter notebook looks like, and I'll show you how I'm going to do that. Okay, so let's say I wake up in the morning and suddenly, some weird thought comes to my mind. Okay, let's say for some reason, let's say I start thinking about the Titanic, right? All of you know what I'm talking about, no? The Titanic disaster, right? So we all know about the terrible tragedy that the Titanic was, right? So I'm thinking about the. So you might be wondering as to like how is this related to the topic that we are, why are we suddenly talking about Titanic? Some few moments back we were talking about, you are learning about quantum mechanics and how to implement quantum mechanics problem. Now suddenly why are we talking about the Titanic disaster? So we all are, because this is something that we all are familiar with. I mean, everybody is aware of what a tragedy it was, right? So I'm going to use a data set. Okay, there is a famous data set which is available. I'm going to use that over here. So now what I'm going to do is right now what I'm thinking is I'm thinking about the Titanic disaster. So what happened was I happened to watch the movie, the Titanic movie, and then in the movie, okay, this was a I think 1997 movie. Okay, in the 1997 movie, the captain, okay, of the Titanic, he said, okay, when the ship was singing, it was beginning to sink. I think it was the captain. I don't really remember who exactly said. He said one famous word: women and children first. Okay, those of you who have watched the movie, you will probably know what I'm talking about. The captain said women and children first. So the question that is there in my mind is, did that really happen? Did that really happen? Did women and children, did they have, if suppose the question that I would like to put scientifically, if I would like to put is, okay, the same question, the very same question, if I were to put this scientifically, I could say something like this. If you were a woman or a child on board the Titanic, did you have a greater chance of survival? So this was the scientifically, this is what I would like to find out. Okay, if you are a woman or a child on board the Titanic, did you have a greater chance of survival? So I'm now casting the same thing. Okay, these first two lines, whatever I have said here, I remembered a movie. In a movie there was a dialogue, and from the basis of the dialogue I got a question in my mind. The same question, now I'm recasting it in a scientific way. Okay, I'm trying to look at it in the terms of probabilities, the chance of survival, what's the probability that a woman or a child on board the Titanic had a chance of survival? Did they really have a greater chance of survival than men, or was it just something that was just said in the movie just for the sake of cinematic effect? So that's what I am wondering. Okay, so what do I do? There happens to be a very famous data set, the Titanic data set. Okay, so it's, let me just show you here. It's probably, Yeah, this is called the Titanic.csv. It's available online. It's a very famous data set. It's a Titanic.csv. It's a CSV file. CSV stands for comma separated values file. So CSV file can be opened using Excel, or I'm using Linux here. So you can open this using LibreOffice Calc also. So let's just open this file and see what's there inside this file. Okay. I hope you're able to see the file. So this is basically just a normal, like just like an Excel file. Okay. So we have so many columns and we have so many rows, different rows. We have lots of rows and lots of different columns. So it contains first the passenger ID, survived, 0 means the person has not survived, 1 means the person has survived. Then the passenger class, name, sex, age. Okay, and I'm not sure about this. The ticket, fare, cabin, and embarked. Okay, so all these details are here. It's basically a database. Okay, so you can also open this using text editor also. If I open this using a text editor, you'll see this is how the file looks like. That's why it's called as comma separated values, because the values are separated by commas. You can see here passenger ID, and then there is a comma, and then survived and comma. So basically when you open this using Excel, what happens is Excel understands it as that whenever there is a comma, that is one data, right? Between two commas, that is one piece of data. So this is one comma and this is another comma. So whatever comes in between is basically one piece of data. So this is what we have. Okay, so this is how it looks like. You will just open it using a text editor. So this data is actually available online. It's a very famous data set. So it's actually available online. So I thought that, okay, maybe let's, download that data. So I downloaded that data and I placed it in the folder wherever I have opened this, my notebook. You can see it here. You can see this, the Titanic.csv, this file. Okay, it's opened over here. So now let's try to read from this file. Okay, so let's try to read from this file. So for that, what I'm going to do is I'm going to use a certain Python package. Okay, it's called pandas. Okay, I import pandas as PD. Okay, I'll explain to you what this really means, what all these words, what they really mean. I'll explain to you. That's what the whole purpose of the workshop is. So right now, let me just give you a demo. Okay, so now what I'm going to do is I'm going to I'm going to create something called as a data frame. Okay, I'm going to create something called as a data frame. I'll call this data frame as Titanic, which will contain all the data. Okay, and then I'm going to read from this file. Read, and I press tab. It will show me that what are the options that I have. Okay, many different options are here. I can read from many different sources. I can read a CSV file. I can read from an Excel file also. It could be an Excel file also. So because it's a CSV file, comma separated values file, I'll select this. So read CSV, and inside this, I need to give the name of the file. The name of the file is Titanic.csv. Titanic.csv. Okay, now run this. It's running fine, no errors. Okay, so now let me see what kind of data it is. Okay, so I don't want to see, because you would have probably, if you remember, when I opened this using a spreadsheet, there were like more than very close to 900 rows. Okay, so I don't want to open the entire database. I just want to see if there, the data is consistent or not. So I just, call this function called as Titanic head. Okay, and then this is going to show me. Okay, so just a sample. It just gives me the first 5 lines, first 5 rows. It will just show me, just to give me a sample of, okay, whether the data is fine or not. So okay, this is what I'm looking for: passenger ID, whether he has survived or not, passenger class, name, sex, age, and so on. Okay, so these are the things that is available over here. Okay, now I want to know, how many people have survived. Okay, I want to know how many people have survived. Okay, so for that, how do I do that? Okay, so I can do that this way. Titanic dot, I want to find out how many people have survived. So you see, if you use Excel, what will you do? Those of you who use Excel, suppose this was an Excel sheet, what will you do? You will create a filter, and in that filter, under survive, you select, I want to find who has survived. So under filter, there are only 2 values, either 0 or 1. You'll choose 1. So I can do the same thing over here also. So I could just, from Titanic, I could just call this particular column survived. Okay, and then I find out the value counts. Value counts. Okay, and let me run this. Okay, this is what it says. It says 0 zero values. Okay, I mean 549 rows are there. There are 549 rows which have the value 0, and there are 340 rows which have 42 rows which have the value 1. So this itself tells you, I mean, it's just numbers, right? But it just tells you the scale of the tragedy that the Titanic was, right? There are more zeros. There are 549 zeros. There are 549 zeros. That means the 549 people have died in the tragedy, and 340, only 342 people have survived that tragedy. So you can actually find out what is the probability of survival. That is, the probability of survival is simply 342 divided by 349 plus 342, the total count, right, into 100. That is going to give you the probability as a percentage. So you could do that. The probability of survival, is 342. I could just calculate that. 342 divided by 549 plus 342, 549.0. I have to put a 0 here because otherwise it will interpret this as an integer, and 342. If it interprets this as an integer, it is going to give me simply a value 0. So it gives me this. So what is the probability of survival? It is around 34%. 34% probability that a person on the Titanic has survived. Okay, so but then these are just numbers. Let's try to find out. Let's see if we can, show this graphically. If we can, because we like visualization. So let's see if we can, show the same thing, the same information. If we can show it graphically, we can do that. The same thing, value counts, but this time I want to plot. Okay, I want to plot over here. What kind of plot? We like pie charts, right? In such cases, pie charts, they give us a very, beautiful and very fun way of representing data. So what I'm going to do is, the kind of plot that I want is a pie chart. Okay, so it gives a pie chart here. You can see here, blue means 0 and orange means white. So you see where we have a more area under blue, less area under orange. So it means more people. These are the people who have died in that tragedy, and these are the people who have survived. Okay, so this gives me a basic idea of, what kind of, what was the chance of survival. Okay, now coming back to the question that I have had. The question was, if you're a woman or a child on board the Titanic, did you have a greater chance of survival? Okay, let's try to figure that out. Okay, so first let's look at women. Okay, so what I'm going to do is, you can see here, there is a column called that. So how do I, segregate? How do I, filter out all the women? There is a column called as sex. So I could use this column, and in that column, I could set the value as female, and that is going to select all the women from this particular database. So I'm going to do that. I'm going to create a new data frame, a separate data frame. Okay, I'll call it as women, and here I'm going to just select. This will be a subset of the Titanic data frame, and what I'm going to do is I'm going to give a condition, Titanic. And which column are we looking for? We are looking for the column sex. So over here, I just put this column name. Okay, and then we are looking for, what kind of values are you looking for? We are looking for it to have the value female. Okay, so we are looking for. So that means basically what it's going to do is, it's going to from this original database, it will select all those rows in which the sex column, it is carrying the value female. Okay, so that's what it will do. So we run this, it has run perfectly. So we have created this database. Okay, so now let's find out of this women, how many women have survived. Okay, and how many women have survived. So we do it in the same way. But this time let me just directly get into the pie chart. So let's say I just copy this code and paste it here. And instead of looking at the Titanic, I'm looking for the women data frame. The women survived value counts, and the plot that we're making is a pie chart. Okay, so now here, blue represents 1, that means survived, and orange represents yellow, that means did not survive. So you can see here, more women have survived, even though in the Titanic, more people have died than people who have survived. But when you look at women, more women have actually survived than, the women who have died. So it means this part of this, if you're a woman or a child on board the Titanic, okay, if you're a woman, yes, there is definitely a greater chance that that woman has survived. Okay, now let's talk about the kids, okay, and the children. Okay, so what I'm going to do is I'm going to create another data frame, kids. Okay, so now this data frame also similar to this. Okay, we are going to create the same data frame similar to this, but the condition I'm going to change now, because obviously I cannot sort out on sex for children, right? I can't do that because children could be male or female. So now I can do the sorting in terms of age. I could do the sorting in terms of age. So let us just keep 14 years as the definition of children. Okay, so I will just replace this column with age, the sex column I'll replace with age. Okay, and then the condition that I'm going to make here is the age is less than equals 14. If your age is less than 14, you are considered to be a child, and you will come in this data frame called as kids. Okay, we run this. Now we want to find out how many kids have survived. Okay, so kids dot survived value counts, and then again I want to pie chart here. You could put a bar chart also, or let me use a bar chart here. You can see here, this is a bar chart. This is 1 and this is 0. More children have survived compared to children who have died in the tragedy. Okay, so that means it shows, yes, if you're a woman or a child on board the Titanic, you did have a greater chance of survival. Now let's look at the men, because the number of people dead is still very large. No, let's look at men. How did the men, fare in this one? So that is easy. All I need to do is I need to just use this and create another data frame called as men. So here I'll call this data frame as men, and instead of filtering on female, I'll filter on male. Okay, now let's see how many men have survived. It has to be the other way around, because otherwise the results will not be consistent. Men, as expected, these are the men who have survived and these are the men who have passed. So you know that the majority of the people who did not survive the tragedy, most of them were actually men. Okay, so this is very quickly I have been able to figure out. Okay, if you're a woman or a child on board the Titanic, did you have a greater chance of survival? The answer, of course, in this case, the answer is yes. I go back here. The answer is yes. All right. So now, immediately after doing this, now another question comes to my mind. The question is, okay, we have found out that women and children have survived, but then there is also one more column here. That column is P class, means passenger class. P class means passenger class. Okay, first class, second class, third class. Okay, P class. So let's first find out how many classes are there. Okay, let's find out how many classes are there. How we can do that? We can do that just by using this value counts. So Titanic dot P class dot value counts. Titanic dot P class dot value counts. Oops, sorry. This has to be code. Okay, Titanic P class dot value counts. Let's run this. Okay, there are only 3 kinds of values. Okay, first class, second class, and third class. Okay, so these are the 3 kinds of values. So maybe the question that comes to my mind right now, okay, when I find this, then there are 3 classes. The question that comes to my mind right now is, did this is the question that comes to my mind now. Did financial background have a role to play in one's survival? Okay, no doubt we are seeing that a lot of women have survived. We have seen that a lot of women have survived, more women have survived, and more children have survived. But then the question is, more children have survived and more women have survived. No doubt we have seen that. But then what about your financial background? If you're rich, did that have any contribution to it? If you're rich, if you're rich, if you're more well off, did you have a higher chance? If you're a rich woman, the question that I have in mind is, if you're a rich woman or if you're a child from a rich family, did you have did that child or did that woman, did they have a higher chance of survival on the Titanic? Okay, that's what I want to know. So you can look at the passenger class. You can see here, just by looking at this, the passenger class and the fare. The passenger class 1, the fare is 77.1, I think. Yeah, I think this is in dollars. Okay, so that time it was in dollars. So $71, and for third class it was $7.25, right? So you can see wherever there is passenger class one, the fare is more. Okay, that means they have paid more fares they have paid more for their tickets. So which means those are the people who could afford it. So people who are in passenger class one, they are the ones who are more financially well off. Okay, so now the next thing that I want to know is, from this data frame of women, how many rich women are there? How many women from the passenger class one have survived? How many women from passenger class two have survived? And how many women from the passenger class three have survived? So this is what I want to know. So I'll just take this code because I'm going to use this. Okay, so let's look at it for women. I want to know how many women from passenger class one. So now what I'm going to do is I'm going to filter on this. For women, I'm going to filter on this. So what I'm going to do is I'm going to use this P class. Okay, I'm going to use this P class. Wherever P class is equal to 1, passenger class 1, women for whom the passenger class is 1, how many of them have survived? Let's look at the pie chart now. You can see here, right? 1 means blue. These are the women from the first class who have survived. A very tiny fraction of women from the first class actually did not survive. Let's look at what happens for women in the second class. Second class, again, chance of survival is better. Let's look at the third class. Almost 50-50. So if you're a woman, even though just being a woman is not enough to survive on the Titanic, if you're a woman from either from the first class or the second class, then there's a better chance that you have survived. Now the same thing, we can apply this for children as well. And we're able to get some, meaningful information, meaningful insights from this. So you see what I have done here. I did not actually open any, IDE for any programming language. All that I did was I started from here. I started with the thought that I watched this movie and a thought which came to my mind, and I downloaded the data and I used that data, okay, to obtain these plots, and these plots gave me some insight. Okay, so just women and children is not enough. Just saying women and children not enough. Okay, what women and children from the upper classes, they are the ones who had the better chance of survival. Now I'll leave it to you. Okay, the rest of this I'll not do. I could go on doing this. I could find out for the same for children. I could find out the same for the men also. Even though some more insightful thing is, suppose I look at the men. Okay, you see that a lot of men have died. A lot of men have died. But if I just break this down into category, the classes, class 1, class 2, and class 3, most probably my hypothesis is men from the class 1, they had a much higher chance of survival than men from class 2 or class 3. So you see this social divide that was there, that we see, that we take for granted in this in our present day world, it was always there. Yeah.
Yeah, Parag, I mean, this is so interesting. Would you please do it for men of high class? We just want to.
Okay, great. Let me just go and create this. Okay, so it's already there, right? So the data frame for men is already there. So you want the men from the upper class, right?
Yes.
Okay, I'll just copy this. I'll just change this from women. I'll make it men. Okay, so this is from class 1. Class 1. Okay, now of course it looks like many men have died, but we have to take this, we have to compare this not with the women. Okay, this one, class 1, you can't compare this with the women. We have to compare this with class 1 for class 2 and class 3 for men. Okay, so let's do that. Second class, you see the survivors are smaller now. Third class, I'm sure the survivors will be even smaller. Okay, I mean, they look more or less the same, but I think this is marginally smaller. So there is a huge disparity. Second class, in case of men, between second class and third class and the first class, there is a huge disparity. So, I mean, that social distinction, the distinction on the basis of, you have money is power. That's what they say, right? That's a saying that we hear, right? Money is power. We're actually seeing that. We're actually seeing that from a tragedy. So this is one thing that we have learned from this particular tragedy. So that's the Titanic. So this is all this I have done using a Jupyter notebook. What I have done here is a Jupyter notebook. Okay, Samrat, I hope you're satisfied.
Yes, yes, yes.
Now
All
the
right.
question is, in which class do we belong?
In which class? Okay, that question I don't think I'll be able to answer it using a Python code. I'm basically interested in finding solutions to our everyday problems. Okay, okay. Now I'd like to show you one more demo. Okay, just to make my case stronger that we should actually start using now you see whatever I have done here. No, whatever I have done here, you can do the same thing using an Excel file also. Okay, the same thing you can do it using Excel file also. It's just filter out and you select the data and then you create charts. But if you do, any of you who has worked on Excel, you will know that it's such a painful process to actually work in Excel. It's such a painful or any spreadsheet software. It's really a painful process. But in when you use a Jupyter notebook and you use Python, okay, especially this package called as pandas. If time permits, I'll show you how to use pandas maybe towards the end of the workshop if time permits, just by using a few lines of code. And also I did not have to do it for everything. I just wrote maybe a couple of lines and I just copied and pasted those lines and just played around here and there. Okay, so that's the power of Jupyter notebook and using Python on Jupyter notebook. Now I'd like to show you one more demo, one more physical demo. Now this is, of course, this is something that it's we know about this tragedy, but then how does it affect us? Does it are we able to relate to that? Can we relate to this tragedy? Of course, I mean we can't, because it happened. We are separated from this tragedy both in space and time. It happened many years ago. It happened many miles away from us, right? So it's not really for us. I mean, we just know about this from the movie, and then of course we have some general knowledge about this, but that's about it. Apart from that, I'm not able to relate much to this particular problem. So let me show you a problem from my own personal experience. Okay, from my own experience. In fact, as recent as yesterday. Okay, the problem was this. Okay, I was supposed to take a lab exam. I was supposed to take a lab exam for BSc students, BSc third semester students from the chemistry and the mathematics department. And you know what? I mean, in the lab, how do we do? I'm trying to simulate a real life scenario. Okay, so in the lab, generally, how we have our this lab exams is we have certain number of experiments. We decide, okay, that experiment number 1, 4 students will do. Experiment number 2, 3 students will do, and so on. We'll decide like that. And then we randomly assign. We just put up, print them on the answer scripts, and we place them upside down, and then we ask the students to randomly pick up, okay, any 1 or 2 sheets, and whichever they got, that's the experiment that they will be doing. So I wanted to simulate that real experience, that the real experience of randomly assigning multiple instances of a fixed number of experiments among those certain number of students. I wanted to actually do that. So how I did that is I used Python coding actually to do that. So again, I imported the packages that I required. Then there are 3 data sets. Okay, one is the students, another one is experiments, and third one is experiment instances. So what I did was I read the data inside this using this pd.read CSV. Okay, so now I'll show you the students. Okay, so students, I just use students.head. I just want to show the first 5 lines. Okay, so you can see here, this is the data that is contained in the students.csv. So these are students from chemistry and maths department. So they in the students.csv, there is serial number, student ID, name, and the branch. Okay, next, experiment instances. Okay, so these are the experiments. These are the experiments that I wanted to do. So there are a total of 11 students. Okay, there are a total of 11 students. So the problem that I was facing is the experiments, number of experiments were 5. So I had 5 experiments, and those 5 experiments had to be distributed among 11 students. These are the 11 students. Okay, so we have 11 students, and among these 11 students, I have to distribute 5 experiments. So what I did was I decided that the first experiment will be assigned to 3 students. Second experiment to 2, 2, and 2. So total 5 plus 1 gives us 11. Okay, so that's how I had decided. So these are the experiment instances that I had chosen. Okay, so now for that, what I did was I created some lists, and then I created a set of keys which I shuffled. There is a package called as random. It can randomize certain number of keys, it shuffled them, and then I created a new data frame, okay, where in which, just like you have, serial number, you have serial number here, student ID, name, branch. So I wanted to join these two data frames and create a new data frame. So I created a data frame where the first column was student number, the serial number, student ID, name, branch, experiment number, and experiment name. And then I use a little bit of this Python coding over here. And then what I did, then I was able to create this data frame called assign. And now I'll show you how this look like. This is how it look like. So you can see here, it has correctly taken, okay, let's say verification of Boyle's law. There should be 3 instances, verification of Boyle's law, 1, 2, and 3. Other experiments, heat conduction, 2 instances, thermal expansion, 2 instances, adiabatic index, 2 instances, and internal energy, 2 instances. So it has shuffled the experiments, and it has provided to the assigned students also. Now in the last line, what I did was, okay, now I want to show this as a, I want to express this. I want to put this in the form of a Excel sheet, because that's what I want to share, because the students, they don't know Python. So I want to share it as an Excel sheet. So I can do that. Okay, just observe the directory here. Moment I run this, a new file will be created. I'll show you. Okay, so here, moment I run this, a new file will be created. You can see here, a new file has got created. Okay, GTP lab test experiments. If I open this, the same information that was there on the notebook, it has passed on the same information over here. And this is what I shared with my students. Okay, so that's basically how powerful, Python is. Okay, so these are the couple of demos that I wanted to actually show you. Are there any questions? If you have any questions, I could take them right now, or maybe I could, if there are no questions, then I could move forward.
Parag, this
yeah.
Jupyter notebook, we have to download, or how to get it?
Yes, that's exactly what I'm going to show now. Okay, so let me close these. Okay, so now coming to Jupyter Notebook, what exactly is a Jupyter Notebook? This is how a raw Jupyter Notebook looks like. Okay, you have to, of course, download it. Yes, to answer how much questions, you have to download the Jupyter Notebook. There is a software called as Anaconda. That's the easiest way to get Jupyter. I will show you how to get this Anaconda, for both as well as for Linux. Okay, just one second. I think somebody is trying to enter this. Okay. So this is how a Jupyter notebook looks like. Okay, so you can see here I have, these are known as what are cells. I'll come to that. So there is introduction to Jupyter notebook. I have written it in this way. It has color coded it. I have put a hash here, and I have written introduction to Jupyter notebook. Okay, so now I can run this. How do I run this? You see, it is similar to, this is known as Markdown. Okay, by the way, it shows that this is known as Markdown. You can see here, it's known as Markdown. Markdown is like, your HTML. If those who have done HTML coding, you write some bit of code and it understands this. I'm sure all of us have used Markdown. At least in WhatsApp, you would have used Markdown. Like for example, let's say I'm typing a message on WhatsApp. Okay, let's say I'm typing a message on WhatsApp. Okay, let's say this is a. Now let's say I want to make certain text bold or italics. What do I do in WhatsApp? You put an underscore and then you put another underscore, right? So whatever comes in between the underscores, that becomes italics. Now if I want it to be bold, then what I do is instead of underscore, I put stars. That is going to make it bold, right? So these kind of these kind of formats, this kind of formatting where you put certain characters and those characters have a special meaning. The Markdown is basically that. So in WhatsApp, actually, we use a kind of a Markdown when we want to make something bold or italics. So what does this hash stand for? It stands for heading. So this is my main heading for this notebook. This is my main heading. Okay, this is the idea. Idea is I want to introduce Jupyter Notebook. So this is my main heading. So now right now it's looking like this. It's not looking the way, it's not looking nice. So what I can do is I could actually run this. When I run this cell, then it will look nice. So I have to click on run, and you can see here, now it's coming nice. The hash is gone. The size of the text has become bigger. Now it becomes obvious that this is a heading. Okay, so now the same thing I have done here. So I have used two hashes here. What is the two hashes? This is a subheading. Single hash means heading. Okay, double hashes means subheading. And then we put dashes here. Let's see what these dashes, what they mean. Let me just copy this part. Give me a second. Let me just copy this part and I'll show you. Okay, now coming back to this cell, okay, you could either click on run or you could press Control and enter. Okay, when you press Control and enter, you see this is how it looks like. Now this is beginning to look like a document which maybe you have typed in your Word. No, this is what it looks like. You have this bullet points, and then we have sub bullet points and so on. So Jupyter Notebook, it allows you to do that. That's the power of Jupyter Notebook. It is an incredibly powerful tool for interactively developing and presenting data science. Because you see, when we say data science, we are not just looking at the code or the results, just like how I had shown you that Titanic analysis of Titanic. So I did not just present to you the code, I also presented to you ideas. I wrote down, right? And this is the question that I have in my mind. So this is the idea that I have in my mind. I presented ideas also, right? So you not only you present code, you also present ideas, you also present your graphs. Okay, so that is what is meant by developing and presenting data science. Okay, so it basically integrates code, the code and the output of a code all in one single document. Okay, it combines visualization, narrative text, mathematical equations, and all other rich media, as we will see through the course of this workshop. In fact, in this workshop, the entire workshop I'll be conducting using Jupyter Notebook only. Okay, all my code, I am not going to do any other software, only Jupyter Notebook. Okay, so all my visualization, all the text, all the mathematical equations, all the everything, all the other media that I'm using, the images and so on, all of these will be there in the same notebook. Okay, so in a nutshell, if somebody asks you what is a Jupyter Notebook, it is basically a single document. Just like your Word document, Jupyter Notebook is also a single document. Only difference is in Jupyter Notebook you can actually run code. In Microsoft Word, let's say you're writing a document, you cannot run code inside that, right? Suppose you are taking a class for, let's say a Python class for students, and you are writing a document, right? And you want to convert that into a PDF. You can't actually put the code inside and then actually run the code also. You have to run the code somewhere else, get the output and paste the output inside your document. But Jupyter Notebook, it allows you to do everything. You can write your document, you can run the code, you can display the output, you can add explanations, formulas, charts, everything. So in other words, Jupyter Notebook, it makes your work more transparent, understandable, repeatable, and shareable. Okay, so you can share your Jupyter Notebook with anybody in the world, and if they run, they're going to get exactly the same results that you got. And the best part is, of course, it is completely free. Okay, so that's Jupyter Notebook. So okay, so Amma, to answer your question, that's basically Jupyter Notebook. Now we will go more into the fundamentals of Jupyter, trying to understand a little bit more of, we'll dissect Jupyter Notebook more. Okay, so here you have, if you remember, we use a single hash. Here we use a double hash. Okay, single hash, when we used, it gave us a heading. When we use a double hash, it gave us a subheading. When we use a triple hash, it will do exactly what's on your mind. It's going to create a subheading. That means genesis of Jupyter Notebook, that is going to become smaller than, the text will appear to be smaller than this particular text that we have written here. Okay, so the Jupyter Notebook, it actually contains a lot of kernels of kernel is, I mean, that's a computer science term for a programming language. That's basically the root. Okay, that's what controls the behavior of the programming language, that controls the behavior of the compiler of the programming language. That is the meaning of a kernel. So there are 3 high-level programming languages. Those high-level programming languages are Julia, Python, and R. R is another programming language. And these are all high-level programming languages which are dedicated to data science. So Jupyter Notebook, it is basically, it contains these three. It started with containing the kernels of these three. Now they have added more kernels of other programming languages also, including SQL and so on. So it basically contains kernels of these three high-level programming languages. And in fact, the name Jupyter Notebook is actually derived from Julia, Python, and R. Julia, JU from Julia, PYT from Python, and R, you can't simply put a R here, you need a vowel, so that's why they put a vowel E here. Okay, so that's basically the three kernels which it started with, and that's why it's known as a Jupyter Notebook. Okay, now you see this image. How did this image magically appear? How did this image magically appear? It did not appear anywhere because I included that image. That image is somewhere over here. That image is here. Day one. That image is here. I could search for this here. The name of the image is jngenesis.png. jngenesis.png. This is the image. jngenesis.png. That's the image. So what I have done here is I have used the HTML code. You can use HTML code also. This is basically an HTML code. In an HTML file, let's say you want to include an image on your website. This is basically the HTML code that you'll be using. You give the name of the source. You use something called as a tags. You use an img tag. Okay, source, the name of the file is this. Then suppose for some reason, let's say this file is missing, then it will show you some alternate text. Okay, if the file is missing, it will tell you that this is an alternate text. And what will be the width of this? Okay, 400 pixels, that's the width. And the moment I run this, if I run this or if I press Control Enter, okay, then this image, it will just read the image and it will place the image over here. So that's how you're able to see this particular image. Okay, and of course, one more fun fact from here is Jupyter Notebook is a strong reference to Galileo Galilei, who we all know is credited with the discovery of the moons of Jupiter. He had developed his telescope, and using these telescope, he was the first person to observe the moons of Jupiter. And in his notebooks, okay, Galileo used to maintain elaborate notebooks. In his notebooks, he used to have all these diagrams of the moons that he had observed and all the astronomical data that he had compiled. All of these were there in his notebook. So in his notebook, you could, if you go online and if you look for Galileo's notebooks, if you look at the images, you'll find lots of text. Okay, you'll find lots of numbers. Okay, he had jotted down a lot of observations and lots of figures, all in the same notebook. Okay, so this Jupyter Notebook, it is inspired by the notebooks that were developed by Galileo Galilei. And actually, you can actually see that in the logo of Jupyter itself. Okay, you see this orange circle looks like this is the planet Jupiter, and these gray dots that you see, those are the moons of Jupiter. So this is a strong reference to Galileo Galilei and a tribute to him. Okay, so Jupyter Notebook, Jupyter, from the three kernels, and the way this name has been given is a salutation to Galileo Galilei. Okay, so that basically is your Jupyter Notebook. Okay, what Jupyter Notebook is, basically it's this. Next, how do I get it? So let's say based on the demo that I have given and based on what I have shown just now, let's say now you're really interested in getting Jupyter. So most of you probably I won't be incorrect in assuming that most of you use Windows. So first I'll show you how to get Jupyter on Windows. Okay, so first, how to install Jupyter. You have to install a software called as Anaconda. Okay, you have to install a software called as Anaconda. You can go to this website, anaconda.com, okay, or anaconda.org. I will ask my colleague Narika to just give a demo of where to go. So let me just stop my presentation and Narika, are you there? Please, can you present your screen?
Yes, sir. Sure. Sir, can you just allow me to present the screen?
Yeah, I'm doing that. Okay, Narika, I think you should be able to present now.
Sir, did you see my screen? Are you?
Just a second. Let's wait for a while. Can you share again? Can you just stop sharing and share again? Narika, is there a problem?
Parag, I think present now option is not available in her. It's not
Okay.
yet showing up in her.
Okay, okay, wait a second.
Ah, now it has come.
Okay, now just try, Narika.
You must grant. You must
Uh,
grant permission in order
Parag,
to
it is
share
written
screen
you
share.
must grant permission in order to
But I
share.
have allowed her to share actually.
Let me try again.
Sir, just a window you can share.
User interested, it's okay.
Samrat, can you just try sharing your screen? Let's see if you can share.
Yeah, I'll try. Yes, in mine one it is possible.
Okay, so I think you can only do that. I'll share the link in. Just give me a second. I'll share the link in the chat. Just a second. Okay, Samrat, I have given
Yeah,
a
I got
link.
it.
Yeah, just open that link. You have to go to www.anaconda.com.
Okay. Is my screen visible?
Yeah, it's visible. Okay, once you are in anaconda.com, you can see lots of tabs on top. You go to products, and under
Then
products, you go to individual edition. Under products, you go to individual edition. Yeah. Okay, so now just scroll down. Just scroll down right till the bottom. Just scroll down.
install Anaconda.
Yeah, it's at the bottom. Just go down. You have to select your operating system also. Go down.
Oh,
Yeah. Under Windows, there will be 32-bit and 64-bit. Download the 64-bit installer. Okay, and just install. It's a exe file. Just install it, and that's it. Okay, that is going to install Anaconda, and then you can start using Jupyter Notebook. That's all you need to do for Windows. Okay, Samrat, I think you can stop sharing your screen. So I'll go
okay.
back to.
Yeah, I have stopped sharing.
Okay, so let me just present mine now. Okay, so I hope you're able to see my screen.
Yes.
Okay, so for Windows, you just have to go here, or you can directly click on this link. Okay, this link is there in this Jupyter Notebook. I'll provide that link. Okay, and then you can just start using. Once you have installed it, okay, you can just start using. All you have to do is in Windows, you have to click on Start. You have to click on the Start button, and then just start typing Anaconda Navigator. Okay, once you click on the Anaconda Navigator, it will open you'll be able to see the Anaconda Navigator icon. Okay, so you just have to, Auma, can you keep on admitting the participants? I think many are trying to enter. So you just start typing Anaconda Navigator and then click on the Anaconda Navigator icon. This is going to open the Anaconda Navigator GUI. Okay, then after that, in that GUI, you just click on under Jupyter Notebook, you just click on launch. So I'll just show you how that navigator looks like. This is how it is going to look like. Okay, when you open Anaconda Navigator, this is what it's going to look like. So these are all the kernels which are available. Okay, all the available kernels are over here, and all you have to do is under Jupyter Notebook, you just click on launch. That's all. Okay, once you click on launch, then it will open up Jupyter Notebook on your default browser. If you're using Firefox, Mozilla Firefox, it will open Jupyter Notebook, this one. It'll open something like this. Okay, it'll open something like this. This is the dashboard. It'll open it up on your web browser. If you're using Google Chrome, it'll open in Google Chrome. Okay, and then you can go to the folder where the notebooks are. So right now I'm in this folder, day one, because this is the day one. So I'm going to go to this folder, and then you can start using your Jupyter notebooks, as easy as that. Okay, now one note is, if you use the Anaconda navigator, it might slow down your system, especially if your RAM is less than 4 GB. So if you have more than 4 GB, then I don't think it should be a problem. Okay, so this is how you can start Jupyter Notebook, okay, using Anaconda. Or you can actually start Jupyter Notebook directly also. This is using through Anaconda Navigator. Or you can just directly open Jupyter Notebook also in Windows. All you need to do is just go to start and just click on start and just start typing Jupyter Notebook. Then the Jupyter Notebook icon will come up. Click on that icon. It will again take you on a browser. It is going to open something like this. Okay, so that's about getting Jupyter Notebook on, to start on Windows. Okay, now on Linux, you can install this. Okay, so you go to anaconda.com, products and individual, and then at the bottom you saw three options. One was Windows, another one is Mac OS, another one was Linux. So you go under Linux, you select whichever bit, 64-bit, you download. It's like 549 MB for Linux. Okay, and yeah, then what you can do is you can just copy this URL and paste it on your browser. That will also download the same thing. Then what you can do is on the terminal, you have to open a terminal. On the terminal, you have to type this command wherever the file has been downloaded. Okay, wherever the file has been downloaded, you have to type this command, bash anaconda, and the name of the bash, the name of the file. Okay, so you have to type the name, this particular command you have to type, and then it is going to do the installation on its own. Okay, then one thing that might bother some people, it actually bothered me for a long time. There is once Anaconda got installed, the Anaconda environment, it modified my prompt, the command prompt that we have in a terminal. When you open a terminal, you have a prompt that looks like this. Okay, I have actually taken a lot of care to personalize my prompt. Okay, so what happened was, in front of the prompt, it just added something called as base. It put something like as base. Okay, so I didn't want that. So there is those who are getting this problem, you can actually fix this. I found a solution to this, and the solution, again, I'm putting this over here. So those are using Linux. If you see that the terminal prompt has changed, you can actually use these bit of code to actually solve that problem. Okay, and finally, you install the Anaconda Navigator this way. Okay, this is how you can get Anaconda installed on your system if it's a Linux system. Okay, so now how to start using the Anaconda Navigator? You open a terminal, okay, and then write down the command Anaconda Navigator. Okay, and then it is going to open the Anaconda Navigator GUI, and then the same way. Okay, under Jupyter Notebook, you just click on launch, and it is going to launch this. But then again, same problem holds good here also. It could slow down the system even on Linux systems also. So I do it this way. Okay, I start the terminal from the terminal. All I need to do is just go to a terminal, go to the folder which contains the Jupyter notebooks, and run the command Jupyter notebook. So let me just show you how I did that. First, let me save this file. Okay, so I'm going to open this Jupyter notebook from scratch. So what I do is, you open a terminal. Okay, if you're a Linux user, open a terminal. Then go to the folder which contains all your notebooks. Okay, for me it happens to be on the desktop. Okay, so once inside this folder, I want to go to this one, WCP 2020. So go inside that particular specific folder. So this is where all my notebooks are, all my data is. So now all you need to do is just type Jupyter space notebook, and okay, this is going to start Jupyter Notebook, and it is going to open it on your web browser. Okay, so this is how it looks like. So it has opened this. Okay, now let me go to the folder which I'm interested in. I'm interested in day 1, and right now I'm doing this day 1 session 1. Open this. You can see on the browser on top, you see is localhost :8888. That means you're getting the content from your local system. You're not getting it from some website online. You're getting it from your own system. Okay, so this is the folder where I was. Okay, so this is how you start Jupyter from the terminal. Okay, so now coming again. Okay, so now we'll get to know the Jupyter Notebook a little bit more. Okay, so all right. So first and foremost, the dashboard. This is the dashboard. So when you open Jupyter Notebook, this what I see here, this is known as a dashboard. Okay, so this is what the dashboard looks like. You can see the dashboard. It shows you all the files, all the running clusters, and so on. So I could go back here and show you files, all the files which are accessible to me right now. If I go to running, it will show you all the notebooks which are right now running. I could shut them down from here. Okay, then if you are doing batch processing, you can do it from here. Parallel processing, if you want to do, you can do it from here. Okay, so that's basically the dashboard. Then inside the dashboard, you have some more commands. You can upload a file. Suppose there are some files that you want to upload, you could do that. Then there is this new one where you can select this. We'll come to that. Okay, so that's basically how the dashboard looks like. Okay, now in any system, any new software, whenever you're learning, the first thing that you need to know after knowing how to start this is how to quit the software. Okay, quitting is really important, because just if you suppose make some mistake, you should be able to just leave it and start all over again. Okay, so always after starting, I always show how to leave it. So how do I quit a Jupyter Notebook? The way to quit Jupyter Notebook is gracefully. If you want to quit, you have to hit the quit button. Here on the dashboard, you have to hit the quit. That is going to close Jupyter Notebooks, all the Jupyter Notebooks, and it's going to close the server also, which is running. Don't leave it like this. Don't simply close the browser. Don't do it. Don't do it. Don't close Jupyter like this. Don't close the browser tab. That will still leave all the this one notebook still running. The server is still running. Okay, the Jupyter server, the kernel, the Jupyter kernel is still running. So you should not do that. Always click on quit. Okay. Okay, coming back to this. Oops. So quitting Jupyter Notebook is done. Okay, so now elements of the Jupyter Notebook. First of all, like I said, it contains lots of kernels. So how do I access the kernels? You can access the kernel from the dashboard. Click on new. Okay, click on new. A drop down will come, and in the drop down you will find out under notebook. Right now in my system, it is showing under notebook. It is showing me only Python 3, because only the Python 3 kernel is installed on my system. For Julia and R, they are not installed. Okay, so that's why it's showing me only Python 3. So if you want to create a notebook in using R programming language, then your R will come here. Okay, so you can select your kernel this way. Or you could have a simple text file, or you could create a folder, or maybe you could start an instance of a terminal right from the dashboard here. So this is how you choose the kernel. Okay, then you have the toolbar. Okay, this is the toolbar. Okay, what we see over here, this is the toolbar. The toolbar has got many options. So we have the main menu, there's a file, new notebook, and so on. You could just explore this. Then you can edit the different cells. You could change the view of the notebook. You could insert cells above and below, and also show you the shortcut. If you want to insert a cell below, okay, I'll tell you what the cell is. You can use A. If you want, above means A and below means B. Then the cells, how you can run specific cells or set of cells. Then some commands for the kernel. Okay, that is also available. So all of this, they're given right here in the main menu, and there are some widgets. Will not be going into that. Okay, and then there's some kind of a help, external help. This means this arrow going out, this is an external help. All this is available right here from the notebook itself. Okay, so that's basically the this toolbar. Okay, all right. So now coming to the cells. Okay, most important, the cells. This is what a cell is. This is what a cell is. Okay, so let me go till the end. This is what a cell is. Okay, this is a cell, and what kind of content the cell is going to take, you can actually control that. You can control the contents of the cell. Okay, you can control the contents of the cell. It is a cell. So how do you change the contents of the cell? You can do that using this option here, the code. Okay, so you click on code, there's a drop down here, then what kind of content you want to have, whether you want to put some Python code, or you want to put some markdown or raw text, or you want to put a heading. So you can choose all any of these four options. Okay, so that's how you can change the cell type. Lastly, closing a Jupyter notebook. Okay, closing a Jupyter notebook, never, just like you don't close the dashboard from the browser, never close the Jupyter notebook from the browser again. You have to do it gracefully because it has to close the server. So the way to do that is you go to file, okay, and close and halt. Okay, that is going to close the Jupyter notebook. Okay, so now the components of the Jupyter notebook. So Jupyter notebook has got mainly three components. As you can see again, this is a cell. Okay, let me just go here. This is a cell. You can see the moment I go here, you see the option, it is showing markdown. That is the text. Okay, the text which I'm entering. If you want a cell to contain only text, then you select markdown. If you want the cell to have Python data, you need to code. Okay, you need to select code. By default, it is always code. Okay, because it's actually meant for programming. So now Jupyter Notebook, there are three components. One is a web application, which we are seeing here. Another one is the kernel. Okay, so kernels are the core of the programming language, and the notebooks themselves. Okay, each of these notebooks. So these are the three components of the Jupyter Notebook. Then the types of cells that we have in Jupyter Notebook, four types of cells, as you can see here: code, markdown, raw, NB convert, and heading. Code cells are for input and output of live code that is run on the kernel. Markdown, so this particular code, this particular cell that I have chosen here, this cell, this is actually a markdown cell, as you can see from here. In the markdown cell, you can actually write and render plain text. You can create lists, you can add web links, you can also add LaTeX code. Okay, in fact, this one is done using LaTeX. So all you need to do is, those of you who had attended the previous workshop on LaTeX, you will know. Okay, how do you add LaTeX code? You just put dollar, right? So in between dollars, in between the dollar, if I put a LaTeX command, it is going to render that also. So like, for example, okay, let's say if I want to put let's say E equals MC square, right? E equals MC square. Okay, see, it's going to render LaTeX code also. So that's the versatility of this. Then suppose you want to put code without any formatting. Okay, then you can select this one. Suppose you don't want any formatting to take place, then you can choose a raw NB convert. And then heading is same as markdown. Actually speaking, these are all markdown only. Okay, sorry, markdown and heading, they are just the same. This is a heading type. Okay, this is actually a heading type, but heading is actually markdown only because they're one and the same. Okay, so same as markdown cells. So you can mention separate heading levels by using the hash sign. So let me show you. Let me give a demo here. So I'll select this as heading. Okay, I'll select this as heading. So I'll give you some prompt here. This is, okay, heading. Okay, then below this, markdown. I can use markdown also to create headings. This is subheading. Okay, again, let me add one more. Markdown, triple hashes, subheading, and one more. Select markdown. I could put four hashes. Okay, so this will be a heading. Font has become smaller, even smaller, even smaller. Okay, so you can create your headings like this. Okay, you can also have bullet lists. You can also have bullet lists. You can create bullet lists using the dash, plus, and star signs. It will give you up to three levels of bullets. You see, when I put a dash here, it is the outermost level. Okay, first item. Then you give a tab space, and after that you put a plus. This will be the sub item. Then another tab space from here, put a star here, that is going to give the first sub item. Okay, similarly here, and you can see the result here. So you can get these different levels of bullet lists in this way. Okay, now let's say code highlighting important. So especially if you're supposed trying to teach students some code. Okay, if you're trying to teach students some code, let's say I want to show some Python code. This is Python code. S equals welcome to WCP. I can actually show you this way. Let me just create this one. So you see, this is a new cell. Okay, this is a new cell. By default, it is code. So let me just put the same line. Okay, so S equals welcome to WCP 2020. The same thing, and print S. Okay, now if I run this, you can see here it is giving me some output. Okay, but can you put the code inside the markdown? You can't put. You're not allowed to put the code inside the markdown. So what you'll have to do is you have to tell the notebook that what you're going to put is basically code. So you can do that using backticks. Backtick is on your keyboard, the key just above the tab button. You will see a small line which is slanting line, which is pointing towards the top left. Okay, so that's a backtick. So you put 3 backticks, you can have multi-level code. If you want to put code within the same line itself, you can just put whatever is the code. This is the code. Print hello world. That's the code. You just surround that with 1 backtick before and 1 backtick after. Only 1 single backtick. It will just put this inside the same line. But if you put 3 backticks, like here, 1, 2, 3, and then 1, 2, 3 here, then if I don't mention Python, it won't know that this is Python. So it will not do any coloring. Okay, it will not do any coloring. But if I just mention that this is Python, then it knows that, okay, this is a Python code. And when I run this, it will, accordingly, it will put some colors. Okay, so here it has put this as red color. That means it's just a string. String is red color. Then this is a built-in function. This built-in function, it has color coded in green and so on. So I'm not really sure if we can use other languages. Let me just try C++ and see if it works. Yeah, it works. Okay, for C++, the color coding is slightly different. Okay. So this is how you can actually include code within your text itself. You can include code. Or of course, you can put the code, but if the cell is marked as code, that will also give you some output. And lastly, you can actually export the contents of Jupyter notebooks into many different formats. So some of these formats are HTML. You could export this into LaTeX, PDF, and so on. So in fact, what I'm going to do is at the end of this workshop, at the end of today's sessions, what I'm going to do is this entire notebook. Okay, I'm just going to export it. I'm going to just download it. By the way, you can see a print preview also, because this notebook can be printed also. You can just print it from here. Okay, not from here. We have to download it as PDF. You can see here, this is how it is going to look like. If you want to print this, this is how it's going to look like. So now what I'm going to do is, you could download this as a PDF via LaTeX. Okay, so you can download this. It will download a PDF file. Let's give it a second. It's basically compiling whatever is there in the notebook. It is compiling using LaTeX. It is compiling into a PDF file, and that PDF file will now be, it's creating this, and I can save. It will be saved on my system. Once it is saved on my system, then I will be able to, view this. Okay. So okay, let me just, for the timing, let me just open with Firefox. This is how the PDF is going to look like. So everything that I have done here, you see, the text, the images, the code, everything is right here. Okay, so this is what I'm going to share with you all. This PDF file is what I'm going to share with you all. So when you access that shared Google Drive, you will find this PDF also. Okay, so that is basically a brief introduction to Jupyter Notebook. So it's now 12:40 almost. So I think, Auma, I think this is a good time to stop for lunch.
Yes, Parag, I think we can stop.
Yeah. So in the next session after, so let's break for how much time? Like 48 minutes or 1 hour? Amma, what do you say?
Now it is
12:40. I think
12:40.
we can join again at 1:30. I think 1:30 is good.
1:30.
130 will be good.
Okay.
Yeah, so let's join again at 1:30. So this completes the first topic, okay, which I had in mind. That is introduction to Jupyter Notebook. So have a basic idea of what a Jupyter Notebook is. In the next session, I will start straight head on. I'll start with Python. Okay. So, and of course, I'll be doing this with Jupyter Notebook only. So you'll get to see actually how this works, how you can actually do Python. So the more you go through this workshop, more you'll understand Jupyter Notebook better. So I don't have to actually spend hours and hours to explain what Jupyter Notebook is. More you see me working on this, doing this Python demonstration using Jupyter Notebook, you'll understand it even better. So in the next lecture, so we will start with the basics of Python. So that will be all for now.
Maybe in the meantime, some of us download the Jupyter Notebook also.
Yeah, sure.
Yeah, then it will be good for students to practice.
Yeah, sure.
And another thing is, for the afternoon, we have a different link. No?
Yes, for the afternoon, it's there in the manual. It's given.
Yes,
sorry,
yes.
it's given in the schedule. That link will be using. We are not going to use this link again.
Yes. It's a reminder for the students, participants. We will be using a new link as per the given in the schedule.
Okay, so we'll meet at 12:30.
Okay then. Yeah. Okay then. Let us meet again at 1:30.
Sorry, 1:30. Yes, 1:30.
Okay then. See you again.